slide, so we can do that. Awesome. So I guess I will share my screen, and then hopefully everybody is able to see this and everything is happy. Okay, perfect. Let me know if anything is not visible. So I'm going to put the, okay, and Steve's having some issues with audio. Is that an issue with anyone else, or everyone else is good? And Jeff, you can hear me okay, I imagine?
Yeah,
Okay.
Lucas, I hear you.
Alrighty, I'll get started then. So I'll put the link to this presentation in the chat, just in case anyone wants to follow along. It's bit.ly /Phidgets_webinar. So that should get you to this page here. So if you do want to follow along, feel free. There's a few links throughout the presentation, so that might be useful. So just a really, basically the idea today is that everyone hopefully will have received their getting started kit in the mail. If not, we'll show you how you can get that. And basically the idea is we're going to be talking about Phidgets, how you can actually use them in your classroom, what they are, all that kind of stuff. So basically an introduction to Phidgets. So to start out, my name is Lucas Pasentrilli. So bunch of information here. Main points here are my email address. So if you do have any questions afterwards, after the presentation, feel free to email me directly. I'll just put that in the chat right here. So it's lmpacent@phidgets.com. So I'm an engineer at Phidgets. Phidgets has been around for over 20 years. We've been selling our sensors. So some of you guys may have one. They look like this. So we've been selling these sensors and controllers for over 20 years, primarily to professional engineers, computer scientists, researchers. In about late 2017, we started really pushing hard into education and basically bringing Phidgets into STEM and STEAM classes and computer science classes and tech classes, basically. So I'm leading that initiative, and that's what we'll be talking about today. So other than that, hobbies, iOS and Android development. So if anyone is interested in that, let me know. I can show you guys how to get Phidgets going on an iPhone or a native app. So that's kind of fun. So taking a look at our schedule for today, as I mentioned, we're going to be starting with what are Phidgets. So just to get everybody up to speed with the tool, we're going to be talking about how you can actually use your Getting Started kit. So again, this is the Getting Started kit. Hopefully everybody here has received this in the mail. I know we had a lot of requests, but if not, we'll show you how to get that. There's two primary ways you can interact with the Getting Started kit and with Phidgets in general. So there's a browser-based method, which is brand new, and that's really good for the kind of the younger students. And then if you are maybe like high school or older, I'm not sure what the group is comprised of, but then the desktop would probably be more suitable for you. We'll take a look at a code review of the Sonar Phidget. So everybody in this group who did request a free kit will have received a bonus sensor, which is the Sonar Phidget. So we'll just take a little look at that, take a look at the code and see what it's actually doing. We won't get too technical today, but we'll just make sure everybody understands kind of the basics. And then from there, we'll be taking a look at some classroom examples. So I have some classroom examples in my slides, and then Jeffrey will be also showing us a short video. And then depending on time, we'll hopefully be able to do a Q&A. I'll be able to stick around, but I know that we want to be on time, so we'll see what happens with that. Perfect. So I guess questions and other things. Hopefully, I think we have a bunch of moderators here today. So I'll try to keep an eye on the chat as well. Maybe if there's a major question, someone can let me know. Other than that, not too much. I'm going to be turning on and off my slides so you can see me better. I'm going to be holding some stuff up to the screen. So that might be something else that's happening. But other than that, nothing too crazy. So taking a look at what are Phidgets. This is the kind of main piece here. So they're programmable USB sensors. So basically what that means is that you plug them into your computer generally. I mean, there is some wireless options, but generally you plug them into your computer, you write some code, generally in Java, Python, C#, Swift, any major programming language, and then you're able to interact with the physical world really easily. So I'm gonna stop my share right here just so we can see my screen a little bit better for this part. And maybe I'll pin myself just to, or spotlight myself. So hopefully everybody can see that. So this is what Phidgets look like. They are these kind of small devices in these black enclosures. So they generally all look like this. They kind of fit in the palm of your hand, and they generally do one specific task. So the Sonar Phidget, for example, this will measure distance. So it'll give you a distance measurement. There's hundreds of these sensors available. So I have a few other ones on my desk. Here I have a light fidget. So this will tell you the amount of light in your environment, essentially. I have a thermocouple fidget. So a thermocouple allows you to measure a very, very wide range of temperatures. This is not actually a thermocouple. This is just shorted, but you could connect an actual thermocouple wire there, and you could detect things like you could measure the temperature of a flame. You could measure freezing water. You could do all that stuff, or I should say ice. There's humidity fidgets. So this one is in your getting started kit. So this one actually measures two things. So this measures temperature and humidity. So some fidgets kind of do more than one thing, but generally they all do one specific task. There's hundreds of these available. So that's kind of like a small sample of what is actually available. How you actually use your fidgets, and we'll kind of go through this again later, but you would take a sensor. So for example, I'm going to be taking my sonar fidget here. You would take a cable. So it's a non-proprietary cable, but we do sell them, obviously, just to make things easier. This is just a 3-wire cable here. So it's going to be hard to see, but essentially a small 3-wire cable. They come in all different lengths. And essentially what you do is you take your sensor and you just plug them in. So just kind of like that, you can hear it snap into place. And then if you want to take it out, there's a little tab on it, and you just kind of pull down and press the tab. So basically, plug in your sensor like that. And then from there, what you do is you take your hub. So the hub is called the Vint Hub fidget. And this is how you connect all of your sensors together, and then you connect this to your computer. So basically you would take any port on your hub. So I will just select port 0 for today, plug it in same way. So you're just plugging it directly in like this, and you don't have to be following along. You do, if you want to, feel free. You can also just listen and learn, whatever you'd like. So at this point, I have a sonar fidget and I have a hub. And then basically what I'm going to do is I'm going to take my USB cable. So this is just a standard USB cable. And I'm going to be plugging it into my hub like this. So now I have sonar, hub, USB cable, and I'm going to plug this end into my computer. So I'll do that right here. And then I'll lay this on my desk. So that is pointing up at the ceiling. So at this point, this is when you actually start coding. So you have the thing connected to your computer, whether it's a sensor or a light sensor or whatever it is, you connect it to your computer, and now you start coding. So I'm going to share my screen again. And hopefully everybody can see those slides. Let me know if you cannot. And then what I'm going to do quickly is just demonstrate a really short Python program, and then we're going to dive back into the code later. We'll look later at Java and Python. But essentially, this is what a basic fidget program looks like. So really quite simple. Even though it's a professional tool, the interacting with it is actually quite simple. So essentially, we'll talk about this later, but if I run my code here, I should see distance values streaming in. So I do right here. So I'm seeing about 2 meters, about 6 feet, and that is measuring the distance to my ceiling right now. So if I were to put my hand in front of this, we'll see that it now is measuring the distance to my hand. And then I can take that away and it'll measure the ceiling again. And Thonny, I'm not sure if anyone here is familiar with Thonny, but Thonny is a really nice introductory development environment for Python. So definitely something to take a look at if you're interested. Phidgets will work with any development environment. So if you're using PyCharm, Thonny, PyScripter, whatever you'd like, it'll work for you there. So that is kind of the basics of Phidgets and how you use them. So essentially they're USB sensors. You plug them in. You're not doing wiring or soldering or breadboarding, anything like that. You're just kind of plugging in the sensors that you want. There's hundreds of them. You plug them in, you write code against them, and then it's really, really easy to get that physical data into your software. So it's really, really nice, especially for computer science classes, where you probably want to, you might want to increase the engagement by bringing in hardware. So you can do that with Phidgets, but then you don't have to change your computer science class into a electronics classroom or a robotics classroom or something like that. You can get the physical stuff, but you can still focus on software. So taking a look at the slides again, programmable USB sensor, hundreds of them available. In terms of the environment, so they'll work on any mainstream environment, so Windows, Mac, Chromebooks, Raspberry Pi. So there's kind of a split here. So for desktop, we support Python, Java, C#, and Swift. And for browser, we support MakeCode, and very, very shortly, we're going to be supporting Scratch. So we'll talk about those as well. That's kind of going to be the next step, talk about the desktop environment and then the browser environment. So other than being really easy to use and really easy to get that physical data into your system or into your programs, the really cool thing about Phidgets is that they've been used by STEM professionals for over 20 years. So if you're following along with the slides, you can click on this link and it will bring you to our real world examples section here. So this is our page of real world examples. I'll put this in the chat too, just in case anyone wants to follow it from there. And essentially what we've done is we've found companies that are willing to talk to us and kind of share their experiences with Phidgets. So what you can do is you can watch videos here. So there's little links down here. You can watch a video and it will be an interview with someone who uses Phidgets in a professional capacity, basically. So this one, for example, is Artisan. Artisan is a coffee roasting software. So it's the most popular one in the world. So if you have any kind of like artisanal coffee in your area or like any small batch roasters, they're probably using Phidgets to roast their coffee. And in this example here, they just talk about the software and which Phidgets are used and why they use them. So there's a lot of these examples available. Reckon Point, for example, is a company based in Texas that does scans of buildings, 3D scans. Dr. Ruben Brewer is a PhD from Stanford who taught at Stanford and talks about how he's been using Phidgets for years. So he talks about them. EOS Light Media. This is a lot of people that do museum design and museum exhibits use Phidgets. Again, because it's really quite simple to use. So they're plugging in, for example, if you wanted to light up an area when someone walks into an exhibit, that would be extremely easy to do with Phidgets because you could have a distance sensor or a motion sensor, and then you could provide power to some strips of lights or to a 120 volt light. So it's really, really easy, and that's why that's used. And then Dr. Toby Jackson, another PhD from Cambridge, he's studying large trees in the rainforest and how climate affects them, and he uses Phidgets. So a bunch of videos there, which are pretty cool. And there's also some slides down here. And again, these are just some more examples of companies that use Phidgets. So kind of, again, some museums, some universities, some companies, lots of cool stuff there. I guess one main point about the real world examples, the nice thing about them is, obviously it's kind of showing you the use case of Phidgets in the real world. And it's also showing students, for example, let's just find one that has a hub. So, it's showing students that, hey, that the device that comes in your getting started kit, that is the same device that you're seeing here being used by professionals. So it's nice to make that connection that you're actually using the same exact thing that professionals are using. And the other nice thing that we kind of find with this is that it also shows students that computer science affects or it has impacts on a lot of different areas. So just because like, for example, Toby Jackson, he's studying trees. So maybe in their mind, they would think, well, I like biology. I don't really like computer science. But this kind of gives them examples of, well, it is still important to know computer science because all of his data collection is being done through software. So it's still a really important skill to have, even if you're interested in chemistry or maybe biology or something totally different. They all, especially nowadays, everything is obviously coming back to computer science. So that's why I think these are also a very important thing to showcase and to have. So that's the basic introduction to Phidgets there. Hopefully I am not missing anything in the chat. So if not, I'm going to go on here. The next thing I want to talk about is the free kit. So I think everybody here probably already received this or signed up for this. But if not, the link is right here. So we are doing a free kit offer. I'll put that in the chat there. Nothing much to note. The only thing for you guys is if you do click on this link, there's a limit of 1 per school. You're all in the United States, so you're fine. And you can basically put the promo code down here. So if you haven't done it yet, there is a promo code. We'll keep that alive for another week or so. And by doing the promo code, you can get a bonus sensor. But essentially, by just doing it by default, you'll get the Getting Started kit, which is the introductory kit that we're going to be talking about today. I guess included in the Getting Started kit, just so we all have an understanding, you're going to be getting that hub. So that's the main piece that connects you to your computer, to all your sensors to your computer. You're going to be getting a humidity fidget. So that's the one that basically allows you to measure both temperature and humidity. And then you get some basic input and output. So you get some buttons, some LEDs, and then all your required cables. So that's what's actually coming in your kit there. So once you actually receive your kit, let's look at how you get started. So there's a link on the side of your kit if you have it with you. So the link is on the side there, and you're not going to be able to see it, but it says phidgets.com/start. So that is how you kind of first, if you see you're just starting out with Phidgets and you're giving them to your students, you can tell them to go to that link there, and it will bring them to this page right here. So this basically shows you the 3 paths that you have to start working with your Getting Started kit and to start working with Phidgets. So basically Scratch is level 1. That's the most basic level, of course. This is probably students maybe grades 4 to 6, and that will get them interacting with Phidgets in Scratch. It's actually quite nice. There's a lot of sensors like the thumbstick, for example. So this is some human input example. There's a dial fidget that we give. So this is another human input. But there's a lot of input devices that work quite well in Scratch and are quite engaging. And as I mentioned, it's not released quite yet, but it will be released in February. So that'll be coming very shortly. So that's kind of the base level. The next step up from there is MakeCode. So MakeCode, hopefully, I imagine some of you are familiar with MakeCode. So that allows you to do the block-based coding and the text-based. So it allows you to switch between blocks and JavaScript or Python, and it's all through the browser. So quite nice if you're on Chromebooks or if you're a Chromebook school, that will allow you to use your Phidgets in blocks or some text-based languages. The kind of third option that you have is the desktop option. So this is generally for high schools or older, and essentially this will let you connect, directly to your computer, use something like Thonny or NetBeans or Eclipse, whatever you're using, PyCharm, that will allow you to code directly against the devices using our actual full-blown API. So the ones that professionals would use, that's what that would do. And it will also allow you to use Phidgets with a Raspberry Pi. So that's kind of like the last layer, the highest layer that you would probably go to. So taking a look at MakeCode to start, I'll just click on this. You'll be brought to the MakeCode editor here. So I'll just put this in the chat in case anyone wants to take a look while we're doing this. But when you get to the MakeCode page, I guess a few things to start. You're going to want to be on a Chrome-based browser in order to actually use the USB sensors through the browser. So if you're not on a Chrome-based browser, so just for example, Firefox does not support this, you're just going to get a message right here letting you know that your browser is not compatible. So that's all that means. It just means you need to go to either Google Chrome, Edge works, Brave. There's a few other browsers that will work. Google Chrome is probably just the most common one. So that's what I'm using today. So essentially what you'll do is you have your Getting Started kit. You have a student who's brand new to Phidgets. The first thing that they'll do is they'll build their kit. So the way MakeCode works, if you're not familiar, is you would click on all these links and they will give you further links down here, basically. So if I click on build your kit here, I'll have some instructions here, and that will pop me into this window. So essentially, when you first get your kit, you'll have to build it up a little bit. Depending on when you got it, you may have your buttons and your LEDs pre-installed. That's kind of the new version. So you can see this little note here. You can just go to directly connecting your hub. So essentially, it takes 5 to 10 minutes. It's quite quick. The only note here is you just want to make sure that you're connecting everything the way it's stating. So that's what the students will be doing to start. They'll just connect their hub. They'll connect that humidity fidget to the back of their box there. And then from there, they're ready to go. So pretty quick there. The first thing that they'll be doing is actually blinking their LEDs. So there's essentially a little course here that introduces them to Phidgets. So we have blinking LEDs, using buttons, changing brightness, measuring temperature, and then a challenge. So each one of these steps has we'll show you here, but they have instructions on what to do. And then there's some practice problems at the end. So if you're looking for basically, how do I introduce Phidgets to my students? This is the way you would do it. This is also mirrored on the desktop version. So we'll talk about that after, but essentially if you're like, hey, I'm using Chromebooks in my classroom, or I'm maybe with students who are grades 7 to 9, and I want to use MakeCode, you'd start with this path here. and you'd basically click on, say, blocks just to start. And it will bring you to this page here. So learn how to blink the LEDs on your getting started kit. So essentially the way that MakeCode works is there's a few things here. I'm going to plug in a getting started kit so that we can kind of work through this. So I'll just plug this one in here. So when you get to MakeCode, the first thing that you're going to notice is, or you're going to want to do, I'm going to unpair my device so we can do it together. The first thing that you're going to want to do is connect your device. So there's this button down here that says connect device, and that's how you actually make the connection through your browser. So we'll click on that, and it will bring up a prompt here that will just have me select my device and connect to it. So it's all in the instructions there. But that's the kind of first thing that you're going to want to do, is make sure that you actually are connected to your device. And then in the tutorials, the way that they function is they have instructions up here. So this first one is about blinking your LED. So it gives students step-by-step instructions. So, inside the forever block, turn your LED on. So you can get hints from this section, from this light bulb here. So this is what they're asking us to do in this step. So we're in the forever loop, we turn our LED on, and then we basically go step by step. And the idea with this one is that we want to create a program that's turning our LED on and turning it off so that we can blink it. So here's what our final kind of project should look like. So if we copy that, this is what our final kind of piece of code will look like. And then if we go to the last step here, it says, you're finished, run your code and look at your red LED. So you run your code by pressing this arrow up here that says run your code. That's how you actually start. And then once you press run, you'll see your LEDs light up. So there it is. Hopefully you guys can see that. And now I have my LED lit up, and it's flashing based on my code here. From there, what students will do is they'll kind of complete these practice problems. So usually teachers will have the practice problems as like a required thing. So before you move on to the next lesson, make sure you show me the 3 practice problems that are completed. That's what we see a lot. They use it for assessment. That's if you want to get a grade or whatever for this, you have a rubric, make sure you complete these 3 steps. These are leveled, so they generally get harder as you kind of move on. So basically that's what the first lesson would look like. Teaches you how to blink the LED. From there, you would go back home, and then you do the use buttons one. So, this one will show you how to use the buttons on the getting started kit. And again, it has the same kind of look and feel as all the other ones. And you have your instructions up here. You kind of go next, next, next. You can see what your code should look like. So for example, here it's asking me to read the button state. So I'm saying if the red button is pressed, I'm going to turn on my red LED and turn it off if it's not pressed, essentially. So again, if I run this code here, I can now interact with my button. So if I push the button, I get my red LED on, and if I release it, it comes off. And again, at the end here, there's some practice problems so that the students can kind of go back into the code, understand it, and manipulate it. So we'll get out of there. That is what so basically, if you were starting with the MakeCode with the getting started kit, you'd want to make sure that you run through this whole kind of top row with your students. It ends with a challenge, and that essentially just gets them building a larger project. So there's a tug of war challenge where they have to create a program that lets them count the button. Basically, whoever presses their button 10 times first wins. So they have to use some conditionals, some variables, all that type of stuff to complete that. There's solutions available to all these practice problems. So there's an online guide for teachers. You can email us to request access, but essentially there's a little breakdown of what is happening in the section, what the final code should look like, and all that. So that is all available. That's the basics of MakeCode. I think we'll probably come back to it. I guess if you're not familiar with MakeCode, it's actually quite nice. I guess just to give you a quick description, if you're not doing a tutorial, so we have all these other tutorials with more on the way. So we have different kits and some math tutorials that are more coming, some sensor tutorials. But if you just wanted to use, say, Phidgets in the browser, you could create a new project here. And for example, I have we'll all have a temperature and humidity fidget on the back of our device there. So for example, if I wanted to log temperature, I can just grab the blocks from here. So I can use a forever loop. I could log temperature. So I'll just grab a temperature block here. And we're going to be on port 3. So the port selection is where my sensor here is connected to port 3. So I just want to make sure I'm actually selecting that here. But if I press run on that, we'll get a live temperature stream. And then because we're logging to the console, we can actually see a graph being generated automatically, which is quite nice. So you can see the data streaming in from that temperature sensor. You have a graph here. And the thing that's actually quite nice about MakeCode is it's really easy to download data. So there's some buttons up here. So I can pause, I can continue, and I can download my data. So if I download this, I'll get a CSV. And this is now my temperature data that was just being logged, which is actually quite nice, especially when you're looking at different sensors. So, for example, if you wanted to bring a pH sensor into a chemistry class, or if you wanted to bring a thermocouple into a science class, this makes it really easy to collect that data. So MakeCode is actually quite a useful tool. But I'll leave MakeCode alone from there. There's not too much to it. Port selection is important. If you don't select the right port, you'll just get errors. So it's pretty easy to identify what's going wrong. But quite a nice tool, MakeCode, especially if you haven't used it before. I would definitely give it a look. I guess switching languages you can just do from up here. So I can just click on JavaScript and it will give me the code here. So pretty nice if you want to do some text-based coding. So that is kind of the browser way to interact with Phidgets. The desktop path. So if you are in high school and you're saying, I want to use Java or Python on the desktop, you have your students select this button here. And that will bring us to like the desktop version of the Getting Started Kit tutorial. So that page looks just like this. And the first thing that you would do is probably have them watch the video here. This is just some more real world examples. So it shows Caltech. It shows a project from Caltech where they use Phidgets as an earthquake seismometer. Basically, they had thousands of these things all across California. A few cool examples there. And then after that, what you would want to do is there's this button right here. So there's a set my language and environment. So you're going to click on that. And then you could basically just choose what you're using. So, I'm on Windows with Python and Thonny today. But if I wanted Java, I would just select Java and it will give me my options for that. Same with Raspberry Pi. So Raspberry Pi, Thonny and Python are the kind of default choice. So quite a lot of options. The idea with Phidgets is that the tool should generally just work with your environment. You don't have to change your classroom to work with the tool, which ends up being quite nice. So today I'm going to select Python and Thonny like that. My website is now configured for Python and Thonny. The setup step, so there's kind of 4 sections here. The setup step is, again, building the kit, so we won't go through that. The main difference between browser and one of the main differences between browser and desktop is this configuration step. So when you are using Phidgets on a desktop, there is a little bit more configuration because you have to add the libraries to your development environment. So for example, this one I selected Thonny. So if you are using Python, you would just follow these steps here. And you would essentially, for Python, just as an example, they all work very similarly. You would find your package manager and you would essentially just say Phidget 22 native, and you would install the Phidget package. So this will bring in the third-party libraries, the Phidget libraries, into your Python environment. So if you're using PyCharm, there's a similar process. Basically it's all listed in these instructions. So there's kind of step-by-step instructions about how you would actually do that. There's also video instructions for students. So most environments have video instructions, but essentially that's kind of one of the main differences between desktop and browser is desktop will of course require a little bit more configuration there. So after they do configure their environment, they will go through these same steps. So again, very similar to the MakeCode path that we saw. This is what they look like. So this is the blink LED section for the desktop variety. And essentially you get the same kind of GIF showing you what you should expect. And then you get your code. So this one we had selected Python. So I'm getting Python code here. But if I did, I can change my preferences here. So if I did want to see Java, I can then get Java code. So it just kind of depends on what you're using. This is base code here. So if I were to copy this code and paste it into a new Python script, for example, and press run, this would then start interacting with my getting started kit through the Python development environment. So that's what they would do, is they would copy that code and they would kind of run it in their environment. And then from there, what they have is they have practice problems again. So these are kind of slightly different than the MakeCode ones, because the code is slightly different. Essentially, MakeCode is a bit of an easier API that interacts with the hardware, whereas this is the kind of full-blown one that professionals use. So some of the practice problems are a little bit different, but again, the point is that they go back into their code and get a better understanding of how to use their Phidgets. And these are also some hover over links here that just give them more information. So essentially what a student would do is they would, again, complete these lessons, press next, and that will bring them to the next lesson, which again is reading the button state. So they would basically just kind of go next, next, next. And then there's a challenge here, which is the tug of war challenge that we saw in MakeCode. So similar kind of mirrored thing. It just depends if you want to work on a browser or if you want to work on a desktop environment. That's essentially the getting started kit. They learn how to use their temperature humidity sensor. There's a few more challenges, again, that can be used for assessment. And then there's also some advanced lessons. So there's basically, because it's a professional tool, there are a lot of layers that you could peel back if you choose to, essentially. So there's things like LED brightness, which we talk about in MakeCode, but it's a bit of an easier definition there. So in the desktop one, we talk about duty cycle. So this is something that if your students are going to university for engineering or computer science, this is something they may encounter, is this term duty cycle. We have events, so we talk about event-driven programming. We talk about error handling. We talk about using an API. So definitely if you're in that kind of like grade 12, maybe higher end grade 11 level, there's some interesting concepts here that can be quite useful. Just taking a look at the API. So all of the sensors will have their own API, and it's just a nice way to expose students to what an API is and why you might want to use it. So, for example, I have a light sensor. How do I know how to get data from it? How do I know what options are available? Like, can I configure it? Can I not configure it? So I think it's a nice way to just to explain an API to them, because APIs can sometimes be a bit confusing. So anyways, so there's a lot of choices like that that are quite nice, especially on kind of the higher end, the grade 11, grade 12 path. So that's how you would essentially use your getting started kit. So when you kind of go home, or you're at home and you want to try to use your getting started kit after this lesson, you would go to this URL here, phidgets.com/start. You'd pick kind of what path you want to take. And then say, again, if you want to pick MakeCode, you would start here at the blink LED section, and then you would kind of work through it. And by the time you get through that getting started kit tutorial, you'll have a pretty good understanding of Phidgets and how to use them. So it's quite nice. And same with the desktop. After you go through this, you have an understanding of how to actually use them, how to make a project, and then you can kind of go from there. So that is the kind of getting started kit basics. I guess to take a look at, let me just check. Maybe there's any questions. Maybe I'll stop talking for 2 seconds and just make sure that there's no crazy questions. But yes, so in the chat, Jeffrey's saying if you switch between environments, you just switch your language. Yeah, exactly. So basically, depending if you want to swap your language or your environment, kind of whenever you're doing it, you just go and change it as you'd like, and the website will just automatically switch. So, yeah.
I think Christopher has a question.
Okay, awesome.
Yeah, just real quick. So the Raspberry Pi environment requires like the full-blown Raspberry Pi, right? It doesn't run on the smaller like Raspberry Pi Picos.
No, you can. Oh, sorry, the Pico. I think the Pico is like the microcontroller.
Yeah, there's no video.
It's not Linux.
Yeah, it's not Linux, right? Okay.
Yes. Yeah.
It would be that embedded Linux system.
Yes. It needs to be running Linux. Yeah, Linux, Mac OS, or Windows, or the Chromebook situation. So another question here, which is perfect because we're just about to transition to that, is do you have a database of projects? So essentially what you would do is on this Learn tab up here. So if you're on the Phidgets website, the educational website, there's this Learn tab right up here. And there's kind of 3 different sections here. So there's 3 levels essentially. Level 1 is the getting started kit. So if I click on that, that'll just bring me to the getting started kit tutorial. Level 2 is device tutorials, and level 3 is projects. So basically looking at device tutorials here, I mentioned that we have hundreds of these sensors available. So what we've done is we've taken a subset that work really well in education, and we've supported them with basically documentation, projects, all the stuff that you would need to have it run in a classroom. So this is where you get information. So for example, if you wanted to use a power plug fidget, which is a pretty cool device, this lets you control power to a 120 volt device. So, you have a page here, you have setup instructions here that show you what that would look like. And then you have code samples here. So, this again is in Java, but I can change this to Python if I want Python, and I get my base code. I get some applications, some practice problems, and I get the API. This one doesn't actually have an API because it's a different type of device, but that's some kind of basic device documentation essentially. And then in that projects tab, so up here we have projects, that will bring you to this page right here. So we have a bunch of projects, a lot for the getting started kit. So if you do just have the getting started kit, for example, and you want to explore more projects there, you can filter over here. You can filter the getting started kit, and that will bring up just specifically getting started kit projects, or you can view all the projects, and they're also leveled here, which is quite nice. So a lot of really cool projects are possible. Again, I guess just this one's actually pretty fun. This is using a Python library. So if you're teaching Python, there's a library called Pinput, which allows you to simulate keyboard presses from your Python program. And essentially what this project is it uses a light sensor. So a light sensor like the one I have here. And essentially it's using that Chrome dinosaur game. And the light sensor is reading basically the amount of light from the screen. And if an obstacle comes, which is black, it will automatically press the space bar. So it's automating this game. So it's reading the color of the screen and then simulating a space bar press all through the Python code. So you can actually see the Python code in this corner here. So it's going to say, if it detects something, it says like jumped or jumping, jumped, jumping, jumped. So it's automating that jump. So there's a lot of really cool projects here, which is quite fun. And there's also some Instructables projects. So there's a link here to an Instructables page. And we're trying to get our Instructables community going a little bit. So these are some more advanced projects, but they're quite fun. A lot of different things you can do. So that's the kind of project page right now. Alrighty. So what I'm going to quickly do, we have 20 minutes. So I'm going to quickly try to get through the sonar fidget using the sonar fidget. So again, this is that sensor that we talked about earlier. This is the one that most of you will have received as part of your getting started kit package. So it looks like this, and it measures distance. So I'm just going to plug this in quickly. And what I'm going to do is I'll just review a project in Python. So this is that one that we saw earlier. So essentially taking a look at Python, what you're going to do is we mentioned you're going to install that package. So Phidget 22 native like this. Once you install this, you then have access to Phidgets. So again, it doesn't matter if you're on PyCharm, PyScripter, Thonny, whatever, it all works. The nice thing about this is that you don't need administrator privileges to actually get Phidgets running. So you don't need a third part, you don't need an install, because we know that can be quite a hassle in a lot of districts. So what you will do in your Python programs is you'll always have your import statements up here. And essentially this is just importing those classes from the Phidget libraries that we pulled in. So you're always going to have a Phidget import. And then depending on the sensor you use, you'll have another import here for that class. First line of code is just creating the object. So pretty simple. Again, the distance sensor ties to this distance sensor here. After that, you always have to open your sensors. So basically before this line of code right here actually runs, you have a software object here and you have a physical device connected to your computer. After this kind of executes successfully, that bridges them so that you can start talking to your device. So you're always going to have a create and you're always going to have an open. After that, you can just start using the device. So it's really quite simple. Here, the call is distance sensor.getDistance. So pretty simple. And what we've done is we've just put it in a while loop so that it's just continually just pulling the data from the sensor. So again, if I run this, we just expect to see distance values streaming in from the sensor. So pretty easy. Adding sensors is quite easy. So for example, if I want to add, I have this light fidget here. So I'll add this to my program. So I'll just take another cable, I'll connect it kind of like I did last time, and then I'll connect this to my hub. There we go. So now I have a light sensor connected to my hub. So I have two sensors connected now. And adding a sensor is really simple. You just would add the class for it. So this one is a light sensor. You would create the object. So again, I'm creating a light sensor here. Oops. It's light sensor, and it is a light sensor. I would open it because you always have to open your sensors. And then basically I would just get data from it. So my call here is illuminance. And because I know how to get the data, I'm just going to write it down. But if you didn't know how to get data, you would go to that device tutorial page, you would find the light sensor, and then you would get the code from there. But the call is get illuminance, and the units in this one are lux. So basically, and I'll just make a new line there. So it's really, really simple to do that. So now if I run this program here, now I'm getting distance measurements and I'm getting a light measurement. So cover the light sensor with my hand, and it should go down to basically 0. So really, really easy to add different sensors and make larger kind of software projects. So it's quite nice to do that. If you are using Java, it is basically the exact same thing. So very, very similar. This is just in NetBeans. The code looks almost identical. So you're going to have that import statement up here. You have your kind of main creation here. So creating a distance sensor, you're opening a distance sensor. And again, you're getting the distance value. So exact same thing. The only difference is that you're going to be importing a jar file because if you're using Java, you'll be familiar with jar files. But essentially that is all you do, and you can run this, and this will give you that same output that we saw in Python. So quite nice there. Stop that. So that is the kind of quick overview of how you actually use the Sonar Phidget. And then I guess just to show you again in MakeCode, what you would do in MakeCode is you would have that, you could do, there's multiple ways you could do it, but the basic way is to create a forever loop. You could log it to the console if you wanted to get that graph, and then you would essentially have the distance here. So I'm on port 0, so that will be fine. The only thing I have to do is I have to connect it because I think I plugged in a new hub here. So I just have to make sure that I'm actually connected. And then I should be able to run that, assuming the other program's not. Yep, so that's fine. And then again, we can get that distance value from MakeCode. So MakeCode is actually really quite nice. There's a lot of interesting things you can do with it. And again, the nice thing is, of course, the fact that you don't need to be tied to a specific computer, or if you have a Chromebook or a device like that, you can still use them, which is quite nice. Alrighty, so that's the very kind of quick overview there. I'm going to kind of transition now to the classroom examples just to show you how people are using these. A few things that people are doing. So this was an advanced case. This was a high school who had a greenhouse on campus, and they really wanted to automate some data collection there. They wanted to, essentially the problem they were having is that a teacher would have to, in the summer months, a teacher would have to drive to the school and check on the plants and make sure the temperature wasn't getting too hot. So they'd have to like open a window if it was too hot or close it if it was too cold. What they wanted to do was have a web page that would just show them the status of the greenhouse. So they were able to do that with Phidgets. We have some projects on our page here for the Raspberry Pi. So I'll just select Raspberry Pi here. So they use this one here, this Make a Website project. And essentially what they were able to do was make a website that was hosted on the Raspberry Pi, display sensor data from it, and they also displayed some graphs. So that's a pretty cool project there. And it shows you the kind of possibilities with Phidgets. So you can do the very basic Scratch, and then you can do MakeCode, and then you can do, there's a big step ladder, which is quite nice. So that was a really cool project. I actually have a similar project running at my house right now. I'm testing a different moisture sensor. So we have this moisture sensor here, and we're testing different coatings on it just for some fun testing here. So you can see here, this is at my place. I've been logging it since the 20th. And I have a graph here, a live graph. So this value is updating. So this coding that we put on the test one is not great. It's providing some weird results, like it's up and down a lot. But this is exactly what they did. So they had a web page. They were able to access it from anywhere. And you can do stuff like download the data and display it. So pretty fun. A lot of students are using it with game design. So really fun in Unity. If anyone's familiar with Pygame or Pygame 0, there's some really fun applications there using sensors as input. Some really cool stuff you can do with that. We had a video of a student at Carnegie Mellon who was doing I don't know if this will come up, but it was called Teeter Feeder plus Unity. Let me see if this comes up. No, maybe not. But essentially, they were using a lot of people are using it with Unity because we have a C# library, a .NET library, so it's really easy to get sensor data into it and have some really fun games. Robotics, of course, there's lots of robotics applications. We have our own rover kit that allows students to interact with motors and all of that. But there's always a lot of stuff going on with robotics. And there's a lot of the science, kind of like aquaponics and soil moisture and all that type of stuff going on as well. So lots of different options. And the nice thing about them, I guess, like we have a little bit of time, but the nice thing about what we're doing is the buy tab here has the information about pricing, but essentially what we've done is we've taken our base pricing for Phidgets and we take 40% off for educators. So this page shows all the different kits and all the different bundles. But essentially, like you can get, a full plant kit for like $25. The scale kit is actually really quite nice as well. That allows you to measure weights. That's $30. So basically it's 40% off what our normal customers would pay. So it generally makes most sensors quite accessible. And the nice thing about them is, they are a higher standard than what you would see for like generic sensors on AliExpress or something. So you should see them last a long time, and the data is you get quite good data out of them. So it's quite nice for that, especially for the sciences. And now with MakeCode, you do have the ability to take any laptop. You don't have to have a laptop with specific software on it. You can take any laptop into a science class, get data, and it's quite a nice tool for that. The pH sensor, for example, is $15, and that includes a lab electrode. So, and you can actually get really high quality data from that. So it's quite nice prices for education. So that is the classroom examples. I'm going to throw it to Jeffrey now for his classroom examples. I'm excited to see these too.
Yeah, this is a surprise for you. Hey, yeah, good evening, everyone. Welcome. Lucas, before I jump in, I saw one question from Brian. He was wondering if there was any Phidgets involving air quality. I know you have like barometer and pressure, but I wasn't sure if there was something specific on air quality.
There's a lot of pressure ones. It depends. You can also use third-party sensors with Phidgets. So there's a lot of this is getting a bit advanced for the intro webinar, but the Vint Hub Phidget, the Vint stands for versatile input. So if you do have a certain sensor that is outputting a voltage, you can use it with Phidgets. We also have some adapters. So maybe you can email me after and we can talk about the specific one you were looking for.
Okay, cool. Thank you. Just small little disclaimer. I encountered Phidgets about 2 years ago. I think it was like a tweet I encountered, and attended a session that Lucas led and got the starter kit. And then I played around with a sonar, developed a little Flappy Bird where I was using my hand to move the bird up and down. And students were just so intrigued with what I was doing on the side when I was playing with it that I decided to go for a grant, and I got about $1,300 to dedicate just to Phidget stuff. And this is our first year, so it's a little raw, and I am not a video editor, but I wanted to show off some of my sick things that have been going on in the classroom, because it was probably some of the most fun I've had this year is watching these students create things beyond what we normally do in class with applied real data. I took off sound, so my hope is to kind of talk over so you can kind of understand some of the things you're seeing. Some of these are projects straight from the Phidget website that students took over. Some of these are things that students thought to do on their own or adapt with what we learned in content-wise. So we're going to kind of get rolling, but you can check out my awesome video editing skills here. Right, look at that, it's beautiful. So first series that we're going to look at is just the starter kits alone, just like what you can do with a starter kit. And so students created this like word scrambler where they scrambled text, and then there was 2 button answers you can see, and then they're basically choosing a button, yes, like which word is the scrambled word, and they only have so much time to do it. We got thumbsticks for every student, which was a big hit. So we developed like mazes, and they're using their thumbstick to navigate a maze around. And if they hit walls, they fall off. And it's just really cool to talk about thumbsticks, specifically voltage, and actually kind of like get a common sense of it. Here's another one. They're controlling the black ball, dodging the other ones. It's just really cool to kind of see the control that we're able to have. We have a scale. So this is really a little harder to explain, but every duck has a special weight to it. So the student created like little puzzles, and if you solve the riddle, you could find the right duck in the room, put it on the scale, and then progress to the next puzzle. So the idea is they had to like find all the ducks in the room and solve it. If you ever did Indiana Jones, this is my Indiana Jones rendition. Basically, if you steal the duck, the weight catches you. So you had to find a way to counterbalance it. The rover kits are probably the coolest part that my students really loved. It's wireless, so it's really, really neat. And you have a chassis that you can build all sorts of sonars. You saw a pretty crazy one with sonars. I'll talk about that in a second, but you'll see some basic examples here. So they're wirelessly connecting to these rover kits. And like in the example, they're just learning to control motors and control the motors go back and forth and things on those lines. This one is a project from Phidgets. They adapted 2 light sensors. And so this is tracking for light on the student's phone. And when it sees light, it drives straight to it, as you can see in that example. This is our triple sonar detector. It did not work fully, but the attempt was to try to get it so it could like drive in hallways and turn and literally loop around the room. But our sonars were kind of communicating with each other a little too much that we had a little issue. We think in the long run, having some laser distance sensors would solve the problem. So in the future, RFID is really cool. So we're scanning different cards and different watches that are here with RFID technology, and you'll see like we're creating a countdown timer. There are cool wireless capabilities. So this is a wireless setup with the power plug that Lucas talked about, and I'm snapping, and you'll see my phone starts charging with my beautiful dog. And so it's just super cool that like we're able to create pretty much anything you could think of. Like we have a clap on, clap off system for a light, or it could be based on sound. So like if my students are too loud during lab time, I could pick up their decibels, and there could be a light that blinks and be like, oh, the bulb's going off. We got to calm down a little bit. And we're just really looking at how do we apply this like technology in different ways. One of my students, I couldn't get a good video of this one, did like an RFID for swiping in and out of the classroom for the bathroom. So like you could have a little light that was on that would tell you when a student was out of the room, and when they swipe back in, they never took the card out of the room, but just used it to come in and out. They knew when there was more than one person in the room. So we didn't have the issue of, can I go to the bathroom yet? They kind of knew whose turn it was. It's just really insane. So it's really cool stuff. The more you dive into it, the more Phidgets I want. It's definitely an addictive problem now, because I definitely spend a lot of time looking on their website going, what else is there? I'll also hand it to Phidgets that when I first looked at them, I think they had like 7 or 8 different Phidgets available for education with their tutorials, and they're really easy to follow. And then I feel like every month that I look, there's a new Phidget in there, and I get really jealous that I don't have them all to follow through. It's really awesome stuff. Applied technologies. And yeah, so that's my little rant about what we did in my classroom. And these are students that had their first programming experience with me in September, and they were doing this stuff by December. So it doesn't take a lot of time, because it is really easy transitions with the code and what you're expected to do. So I'll pass it back off to Lucas.
That's awesome. Thanks for sharing that. That's really, we're going to add some of those to the website for sure. I like some of those projects. Very cool. Awesome. So I guess we don't have too much time left. So this is our kind of main contact information. So education@phidgets.com. If you have any questions, I had my email. I'll put that kind of back in here just in case you want to contact me directly. So Lmpacent@phidgets.com. Maybe if you were, I forget, it looks like Brian was asking about the air quality. Feel free to email me and we can chat about that. That's the main website link that we kind of showcased today. And we are pretty active on Twitter, so it's a good way to just kind of keep up to date with us and see what's happening. We post new projects and events and all that type of stuff. I'll stick around for questions. Hopefully that was, I mean, it's a lot of content. We just added the kind of the browser-based stuff. So there's a lot of content there, but hopefully you were able to kind of get something from that. If you want, I guess one thing I'll just quickly share, there is a news tab up here. So you can see the news tab on the education site. We host webinars kind of just like this monthly at Phidgets. And we have one coming up on February 3rd that's getting started, and then we have a Make Code Basics on the 10th. So these are free webinars, so if you do want to sign up for a future one, that'd be awesome. And if you just want to kind of get a better, you want to replay, I know this one's going to be recorded, so that'll be a great kind of resource there. But there's also some here that you can watch replays of. So if you just want to kind of get a little bit more of a look into what's happening, those are some good resources there. But yeah, I'll appreciate you guys all taking some time out of your night to watch this. Hopefully everybody was able to get their free kit. If not, feel free to email me or to fill in that form that we mentioned earlier. But yeah, we do appreciate everybody taking the time, and we hope that everybody found this useful, and definitely stick around for some questions.
Cool. Thank you so much, Lucas. This hopefully some educators here get a chance to bring in some real world data to their code. And again, it really takes out the electronics part, which could be a good or bad thing depending on what the course is about. But if you're focusing on software, it's definitely a really nice solution to get that data still. Before we fully close out, just a couple quick housekeeping items. Save the date for February 24th. We're asking Brian Howard to come. He's in this room now, and he's going to share some of his Kapoor Center knowledge. So we're really excited to learn about what he's been learning about. So we'd love for that. And then the other big date is on March 19th. We are holding a CSTA / Lmpacent unconference. It's a Saturday morning. We're going to start around 9 a.m. Hopefully hear from some pretty cool students that are in college that have earned internships at big tech, and then also hosting a lot of other little just like sessions that everyone can join. It will give some ACT hours, 48 hours, and things along those lines too. And there might even be some cool prizes coming out. So stay tuned. We'll have some registration information on that. And then our final, just small little closing is we did invite all of our chapters in Pennsylvania to join us tonight because we knew this was going to be a really awesome night. We'd encourage you to consider joining all of the CSTA chapters, regardless of where you are in Pennsylvania. So I did post all those links in the agenda as well. Everyone's doing great stuff. You can always pick and choose where you attend, and just stay connected. So those are our hopes. Thank you all so much for being here. Again, we'll hang out for a little bit. If you have questions, feel free to talk to Lucas for a little bit, and we'll go from there. Thank you.
Thanks, everybody.